All right, number one, I got an answer for that, which is great. What are the three external sun layers in order from outside to inside? With my glasses here. Okay, and as Sanaya correctly stated, it's going to be first the corona. Okay, oh, my bad. The corona, the chromosphere, and then lastly, the photosphere. So outer to innermost, corona, chromo, and then photosphere. Number two is going to be which of those is the hottest of the three? And it is going to be the corona, right? So surprisingly enough, the outermost outer layer is the hottest. And we talk about corona, that's a Latin term for crown, because the rays of the sun, which are the corona, look like a crown. The same way with the coronavirus, they named it coronavirus because it's the virus itself has a bunch of like crown-like structures or spikes on it. Again, we call that the spikes. That's kind of represents a crown, right? So that's why it's called the coronavirus, or also known as the corona on the sun. And then number three, last one. Okay, which again, what are sunspots? Sunspots are these darker areas of the sun that randomly pop up on the sun's surface, and those are cooler areas caused by the magnetic fields. There's a bunch of think of the sun like a ball of fire and electricity, and there's a bunch of static flowing all through it. And that static, sometimes it disrupts the way the energy gets around the sun, and that can cause some areas to get a little cool temporarily. Okay, so I'll leave that up for a moment. Make sure to get pictures of that. Add that to your notebooks for page 2 or 3B. Again, like I said, we're going to have a notebook check here in the next 2 to 3 weeks. So be on the lookout for that. Instead of having a notebook extra credit, I'm just going to make things easy. I'm just going to have a YouTube video extra credit. So I'm going to post a really cool YouTube video about solar storms, and you guys can send me some facts on that for extra credit through my direct messenger. Okay, and I'll add that as bonus points to your lowest graded assignment. Moving on, guys, table of contents is the same as yesterday. Page 1, the Unit 7 table of contents, and pages 2 through 3, the external sun features, the same as yesterday, so I'll leave it up for a moment. Okay, and let's continue then from there with our first practice question. Again, to get participation, please answer in the chat. Number 1, what sun layer is where sunspots are found? So we talked about the layers, but which one is where the sunspots can be spotted? Is it A, photosphere, B, chromosphere, C, corona, or D, core? Please answer in the chat for your participation. Answer in the chat. Which one is where we have the sunspots occurring? Okay, thank you, Sanaya. Again, I got Sanaya getting great participation so far. I need some other people to answer. Isaac, thank you, sir. Oh, Diego, thank you. Evelyn, thank you. You guys are crushing this question so far. Doing a great job. 10 seconds. Take about 10 seconds. Lakia, thank you. 3, 2, 1. Shout outs to everybody who answered. That includes Lakia, Evelyn, Diego, Isaac, Sanaya, all getting the right answer. It's going to be the photosphere, guys. The photosphere, hence the sphere we can see like a picture, like a photo, yellow in its appearance. This is the one that also has the little sunspots. And if you guys remember from the video from yesterday, the sun is so massive compared to the Earth, you could fit 10 Earths inside of a usual sunspot. So pretty crazy to think of it. That's how big these sunspots actually are. Okay, here's an interesting video I'm going to play. It asks us, what would happen to Earth/us if the sun disappeared? So I want to emphasize how important the sun is to life on Earth. What would happen to us? How long would we survive? What would happen to our planet? I'm going to give you guys a moment to jot that down or get that picture. It's going to be on page, page 2 or 3B. Only video question of the day. All right, let's go ahead and check it out. So what would happen to us if the sun just turned off like a light bulb? How long would we survive? What could we do? What would happen to our planet? How long would it take to change, right? Let's go ahead and check it out. What if the sun suddenly disappeared?
What if the sun disappeared right now? Would you be able to handle eternal darkness? Cold temperatures? How about flying off into space? The sun is the only star in our solar system, and it gives life to everything here on Earth. Would we even be alive if it vanished? This is What If, and here's what would happen if the sun disappeared. The truth is, we wouldn't even notice for the first 8.5 minutes.
Okay.
This is how long it takes sunlight to travel to our planet. So even if the sun disappeared, its last ray of light would take 510 seconds to reach your skin. And what about gravity? The sun is the dominant gravitational force in our solar system. It has all 8 planets moving around it. So if the sun disappeared, would we fly off into space? Yes, but not right away. The force of gravity turns out to have speed too. In his theory of general relativity, Einstein proved that gravity is just as fast as light, and not instantaneous as was previously thought. This means the Earth would still be orbiting a recently vanished star with no clue of the upcoming darkness. But just for 8.5 minutes. When the last of the sun's rays reach the Earth, eternal night wouldn't be our only problem. The very same moment the sun disappeared from the sky, Earth would start traveling into space at 18 miles per second. Assuming the Earth didn't collide with any other planets or asteroids or get sucked into a black hole, it would be moving in a straight line for 43,000 years before it found another star to orbit. But you wouldn't have to worry about that. Within 2 seconds, the moon would go dark, since there would be no sunlight to reflect. But the stars would still shine, and your electricity would still work, unless it's powered by solar panels. However, gravity and illumination aren't the only things we rely on the sun for. Plants need the sun for photosynthesis. Turning light into energy is how plants stay alive. Without sunlight, most small plants would be dead within days. Larger ones, like trees, would survive for several decades due to their slow metabolism. This would knock out the bottom tier of the food chain. Most animals would die off slowly. Only scavengers feeding on the dead would remain until they froze to death. Because within a week, the average temperature on Earth would drop to a bone-chilling 32 degrees Fahrenheit. And by the end of the first year, minus 150 degrees would be the new norm. And it would keep dropping until stabilizing at minus 400 degrees Fahrenheit. The oceans would grow colder too, but just on the surface. Thanks to geothermal vents, they would remain liquid underneath, despite being buried under a thick layer of ice. So if you're lucky enough to survive, consider moving to the ocean floor. In the end, the organisms living around those geothermal vents would be the only living beings not to notice any difference. They don't need the sun to live and could continue to thrive for billions of years until the planet became a frozen chunk of rock drifting in space.
All right, so some scary stuff there, right? We can see now how important the sun is to our life on our planet, obviously. Some key things there to note. The Earth is going to fly into space. It's going to be like an asteroid in and of itself. With no sun, it's gonna mess with our gravity. It's gonna mess with our orbit, and the Earth's just gonna float around into space until it finds another star, and that's gonna take up to 40,000 years. So scary situation there. Secondly, plants would die first because they need sunlight to live and survive. And from there, I would honestly say that humans and animals, we're lucky if we get to a year, months to a year. I mean, in 1 week alone, you're going to see freezing temperatures. So Florida, you're going to see snow in 1 week. That's how drastic the change is going to be. And then over time, it just gets colder and colder till it's way below zero, and there's just nothing even alive on the surface. I mean, you've got to go underground. You've got to start fires underground, to kind of stay warm, and hopefully, portion what's left of the food on the planet once the plants and animals are kind of just disappearing. So tough situation, but not likely to ever happen. The sun's going to be around for another 5 billion years approximately. So we're safe, but if it did go out, what would happen? We'd like to know, right? Okay, what I want you guys to do is you're going to go to page 3B. We did the first half of the sun diagram yesterday. We're going to hold on to that. That's going to be continued on Monday. But I want to talk about 3 terms that are actually on your newest vocab. These are 3 phenomena that happen on the surface of the sun. So 3 things three crazy things that happen on the Earth, the surface of the sun. So let's take a look. If we look here, the title of page 3B is going to be Sun Surface Phenomena, as in interesting things that are unique to happening on the sun's surface. So that's going to be the title of page 3B. Okay. And the first one is the longest one. I'm going to give it to you right now. It's going to be solar wind. I'm going to give you guys a moment for that. Solar wind. Take a picture, write it down. Keeping things quick today. And wordiest one, so I'll give you a moment. Again, we're on page 3B, guys. Our title is Sun Surface Phenomena. Our first of the three terms I want to go over is solar wind. Solar wind. Okay, so let's get into talking about it, guys. So just like the Earth has an atmosphere, the sun has an atmosphere. So that also means the sun has wind. Okay, and this wind is going to be blown into space. It's these supercharged ion particles go out into space, and you might think, oh, that's scary. That's going to damage the Earth, but actually, the Earth has a magnetic field around it from the Earth's metal core, and this shield blocks a lot of this radiation from the sun. It blocks the solar wind. Now, parts of it go around the shield and get into the poles a little bit, but it doesn't actually go into the planet. It just comes down. It just goes down and appears as lights. We call those the northern lights or the aurora borealis. So if you've ever heard of auroras, okay, this is when those those charged particles are interacting with the atmosphere of the North and South Pole. Okay, again, this is going to cause the northern lights, also known as the aurora borealis. Let's check out a little video clip that kind of breaks it down for us a little better, a little more here. And that's going to be, I'm just going to play the first 2 minutes of this here. So how does solar wind work? What creates these auroras? Kind of a strange video, but it kind of makes the point and interesting nonetheless.
Every second, 1 million tons of matter is blasted from the sun at a velocity of 1 million miles per hour, and it's on a collision course with Earth. But don't worry, this isn't the opening of a new Michael Bay movie. This is the journey of the polar lights. The northern and southern lights, also known as the aurora borealis and aurora australis respectively, occur when high-energy particles from the sun collide with neutral atoms in our atmosphere. The energy emitted from this crash produces a spectacle of light that mankind has marveled at for centuries. But the particle's journey isn't just as simple as leaving the sun and arriving at Earth. Like any cross-country road trip, there's a big detour and nobody asks for directions. Let's track this intergalactic voyage by focusing on three main points of their journey: leaving the sun, making a pit stop in the Earth's magnetic fields, and arriving at the atmosphere above our heads. The protons and electrons creating the northern lights depart from the sun's corona. The corona is the outermost layer of the sun's atmosphere and is one of the hottest regions. Its intense heat causes the sun's hydrogen and helium atoms to vibrate and shake off protons and electrons, as if they were stripping off layers on a hot, sunny day. Impatient, and finally behind the wheel, these free protons and electrons move too fast to be contained by the sun's gravity and group together as plasma, an electrically charged gas. They travel away from the sun as a constant gale of plasma, known as the solar wind.
And what's going to happen is the solar wind is going to interact.
The heavy storm stresses
with our magnetic shield. The shield is going to protect the planet from getting harmed by these particles. But the particles do intersect at the poles. They kind of go closer to the surface. And the atmosphere there is going to stop them there as well. So once they get to the atmosphere, you're going to see as a result, again, those lights that we see oftentimes, many pictures, those aurora lights there. Again, that's going to be caused by solar wind. So just a quick breakdown of how that works, right? Exiting the sun, going onto our planet. Okay, let's do two more quick vocab terms with our stuff. I did give my in-person students time to research in class with their phones because we're not in person and a lot of you are using your phones to watch this. We're gonna skip this, and I'm gonna help you out. So our next one is solar prominence. On the second to third one, guys, we're almost done here. Solar prominence. Okay, and think of this like again, these are all things that happen on the surface of the sun. Think of this like a fire rainbow. It's a fire rainbow that it exits the surface of the sun, then it rains back to the surface. So we can see that kind of here in the GIF on the bottom left. So arc of gas and plasma goes up and back down, kind of like a bow, a ribbon or a bow, right? So ejected from the chromosphere and condenses and rains back to the surface. So I'll give you guys a moment there, take a picture of that. I got a little 5-second video clip that shows you a really good high definition example of one of these. Okay. So like I said, on the next, test, you're going to see online test, you're going to see, it's going to say like solar wind, flare, prominence, storm. Those all sound so similar and seem the same, but they have slight differences. That's why we're breaking these down here. So let's take a look at this 5-second clip here, 10-second clip of NASA footage of these solar prominences in action. You're going to see this fiery plasma rain here with this video as well. So see that? Really cool, beautiful sight there. Of that. And that's what's doing that is the magnetic energy flying off the surface of the sun. Kind of like a little static charge. That static charge is going to bring that superheated plasma gas up with it. It's going to drop it as well. Okay. Last one of the day, guys, before we do our last question and call it a day. Okay. Is the solar flares. Solar flares, guys. So, yeah, it's similar. The magnetic energy is going to eject this gas and this plasma off the surface, but instead of it returning in a bow, it's going to just go off into space. It's going to think of it like a fire explosion going out into space. And we can clearly see them in the bottom left. Now, you may be thinking, oh my gosh, this is scary. This is going to harm our planet. Not exactly. The magnetic shield is so strong on our planet that it still protects us from these. When these get bad, though, what it can do is really mess up our satellites, which is going to mess up our power and our internet. So that's worst case scenario in a lot of ways. So we've gone over solar wind, solar flares, solar prominences. I'm going to give you a video for extra credit on the main page of our Canvas. It'll just be posted as an announcement. You'll write 15 interesting facts from the video, and then you'll just send it as a message, and I'll count it to points to your grade. But yeah, let's go ahead. Let's do our last question of the day. It looks like no one's had a question in the chat. Before we sign out here, last question for our participation. Which solar phenomena is the cause of the northern lights or the auroras? Is it A, solar flares, B, solar prominence, C, solar wind, or D, sunspots? What is your answer? What is your answer? Please put your answers in the chat. I need answers in the chat for participation. Last activity of the day. All right. Thank you, Joseph. Thank you, Evelyn. Thank you, Diego. Again, which of the things we've just talked about causes the auroras? Thank you, Sanaya. Got about 10 seconds. I need more people if you want more, the full participation. Yorkies, thank you. Isaac, thank you. 5 seconds. Okay, so the answer, I want to give shout outs to, looks like Evelyn. Just Evelyn, the answer, guys, is letter C. Congrats, Evelyn, for getting that. Going to be solar wind, going to create the northern lights and the auroras. Again, prominence is like a fire rainbow. Flares are going to be going out into spaces as like an explosion and ejection, and it's going to stop satellites. Let me go ahead and double check attendance here. Looks like we've had a few people join us a little late. Do not